Hi, welcome to Casual F#. Today we're going to be talking about examining and querying data using F# collection functions. This episode was inspired by this wonderful tweet from Alistair Ray, which says, yes, you do want all of Great Britain's buildings in a massive shapefile set. And he was right, I did. So I very swiftly downloaded these, and what you end up with is this, which is a set of shapefiles that describe, as he says, the shape of every building in the United Kingdom, and some other auxiliary information which we actually won't use. I should also bring your attention to the license, and at the end of the video we'll actually do some acknowledgements for the license, but basically it's free data. So looking at this data, I thought, well, what can we do with it? And one of the interesting questions we can ask of the data is which building in the UK is the biggest? I thought that might be quite an interesting thing to try and answer in a few lines of code. So let's just dive in and see what the data gives us. And to do that, I've downloaded this NuGet package here called aegis.shapefile lib, which is a very nice library of functions which will let you access shapefiles, which is what we've got. While I'm here, I should also say that I also added a reference to system.drawing because Shapefile Lib returns positions as pointfs, and pointf is a structure which is provided by system.drawing. So anyway, when I don't really know what I'm doing, what I often do is just make a function which I'll call demo1, takes no particular arguments. And let's say, let's shapefile equals, and let's just see what that EGIS library gives us. We've got shapefile lib here. And what have we got? So we've got a DBF reader. The DBF file is kind of metadata about the shapes. It's not what we're interested here. But we do have this shapefile constructor which is used to load, render and query data in an Esri shapefile. So that kind of looks like what we need. And it wants a shapefile path. So let's just have a literal there for now. If we go back to Windows Explorer, because I'm on Windows here, let's start with Wales, which, if you didn't know, is one of the countries of the United Kingdom, the one on the left hand side that kind of sticks out. And I'm going to do Shift, right click, copy as path. I can just paste that there. So there we go. I'll just complete the syntax of that function by returning unit. And that kind of seems to be fine. If I hover over shapefile, it is a shapefile type, we don't actually use it. I do slightly wonder if it's disposable, though, being quite a substantial object, so I'm just going to try typing use instead of let. Seems to like that. That's probably a little bit more lightweight on the old memory. So now we've got a shapefile. What can we do with it? Let's just type sf dot, see what we get. Ooh, there's a record count. All sorts of interesting stuff. But the one I homed in on, if we just filter the ones which have got get in them, is get shape data. And that seems to take a record index. So it sounds like you can get the shape data if you've got a record index. And it also looked, if you notice at the beginning, there's a record count. So I guess we could be naive and say for I in 0 up to record count -1, so standard looping stuff, do get shape data for I. And let's have a look at what shape data actually is. It's a read-only collection of point arrays, which is interesting. So we can kind of examine that. Let's just see if we can treat a read-only collection as a sequence. So we'll pipe it into, and by the way, to get that triangle, I'm using a particular font, but I just actually typed vertical bar greater than seq dot, let's just iterate over the sequence. And I'm just going to call that value C. And we kind of got a sequence of sequences or a sequence of arrays. So let's just put a little separator in so we can see what's what. And C, if we hover over C, it is that point array, so we can iterate over that as well. This is P for point. And I'm just going to use %A as my format for printing out that point. And I can get rid of where I return this unit now. Little typo there. So that ought to print some stuff out. Now I'm a bit nervous that this file is quite big, so I'm actually going to limit that to 10 items and just comment that out for now. So to get this running, I'm going to go to Solution Explorer. I'm going to send all references to F# Interactive. So that will make aegis.shapefile lib available there. I broke my code slightly by not typing a do there. And I should be able to send all that to F# Interactive. There we are, we've got demo 1, so let's just run that and see what happens. Right, well, quite satisfactory. We have got in between our kind of separators, I probably should have done a print fn there to get a new line. We have got a bunch of points. And now it's a bit unclear from that how this stuff is broken up. So I'm actually going to put another printf. I'm going to make that a printfn. I'm going to pop another one at the beginning of the loop there. So we've kind of got major and minor divisions. Let's try running that. Okay, it looks like, certainly at the beginning of the file, that although this is a collection of arrays, each collection element seems to actually only have one array. I suspect that what is going on here is that where a building has voids in it, like maybe a big hospital with kind of gardens within the building, that's when it's going to need more than one polygon to represent the building. So that's why you have the potential to have multiple arrays of points within one building. That's just a guess though, but it's a reasonable guess, I think. Right, now I'm not entirely happy with this. The reason I'm not happy is because you've got a for loop in there. There's no real shame in using for loops. I think last time I counted, the F# compiler itself had 400 of them, but one's always a bit suspicious about maybe one can use something a little bit more functional. And indeed you can, because if you think carefully, this is the function we want to be calling to get the nth element. So if we kind of want a sequence for all the elements, what we can do is do a seq.init. That creates a sequence. How big do we want the sequence to be? We want it to be record count big. How do we generate one element of the sequence? We take an argument I, which the construction of the sequence will populate for us between 0 and record count -1. And the rest is actually unchanged. So that's how we get rid of loops in this case. Let's just check that still works. It doesn't work. What's going on there? Object reference not set to an instance of an object. Now, we're always told in the F# propaganda that that can never happen. Well, it kind of does sometimes. And I suspect it's because what's happening here, and you quite often get this with sequences, is because a sequence is a lazy thing, we're actually getting the shapefile being freed before it's gone through all the elements of the sequence. So we just need to get rid of that use. Let's try that. There we are, back to the same data. Now, how do we make this code a bit more functional or a little bit more concise? Well, look at this lambda here. It takes one argument that's called I, then it immediately uses that argument here. So maybe we can actually get rid of the lambda just call get shape data there. I might have to lose my printfn there. We'll have to fix up our indentation a bit. Get rid of a redundant bracket. So our seek.init is getting a record count still, and its initializer is just a function which luckily enough takes the one argument which seek.init will provide it anyway, so we can dispense with the lambda altogether. Let's see if that works. There we go. Now, it's run away with me a bit because of course I forgot to limit it to just a few records. So I'm going to actually reset the session, resend the references, and to do the equivalent of that limitation we could just say seek.take 10. There we go, back to normal. Okay, now let's think back to the task we actually set ourselves, which was to find the largest building in the UK, and I'm going to simplify slightly by defining the largest building as being the building with the biggest perimeter. That's including, by the way, measurements for any voids within the building. So when a building is a set of kind of nested polygons, the inner polygons being gaps, light wells or whatever, then we'll include those inner polygons in the perimeter measurement. So we are going to need something that calculates the distance between 2 points, because to calculate the perimeter, basically we're going to divide the polygon up into lines, measure the length of each line, add them up, and the job's a good one. So I'm going to open the system.drawing namespace, because like I mentioned before, this Aegis Shapefile Lib thing uses pointfs, and pointf is a drawing structure. And let's think back to our high school or possibly earlier maths. And the way you measure a distance is you take a point and another point, and we apply Pythagoras' theorem by taking the vertical and horizontal distance, squaring them, adding them together, and then taking the square root of the result. So to square something we go power of n. To get the distance between point 1 and point 2 we just subtract. And we're squaring, so raise to the power of 2. That should say dx. Same with y. Add them up and take the square root. There we are, job done. Just create a typo there. The distances we're dealing with here are such that this is the right function to use. For very long distances you have to use what's called the great circle distance, which takes account of the curvature of the Earth, but hopefully the UK doesn't contain any buildings that are big enough for the curvature of the Earth to be a consideration. Let's just quickly test that out. So let's say make a couple of points. Let's go from 0. And by the way, pointf needs single precision floating points. That's why I've said f there. Well, let's just do the trivial case. And of course, these should be an automated test, really. So this is just a demo. And just print that number there, missing a bracket as usual. And that should be 0 because we've got the same point. So let's firstly send the distance function over. Secondly, try it out. Oh, I forgot to include system.drawing when I sent that over, so let's try that again. There we go. Yeah, distance of 0. Actually, I'm just going to drag that to the bottom so we don't have to keep switching. So let's go from a point, let's just move 1 in one direction. The distance between those two should be 1. Spot on. If we go 1 unit in both directions, the difference should be, I think, the square root of 2. Yeah, so that seems a reasonable distance function. So how are we going to work out the length of a polyline? Because effectively the perimeter of a building is made up of a polyline, or a sequence of lines, each of which is defined by a starting point and an ending point. Well, that is a lot simpler than you might think. We're going to take a set of points. So that's a point F sequence. So our polyline can have any number of segments. We're going to take those points, and we want to measure firstly the difference between the first and the second point, and secondly the distance between the second and the third point. And anytime you've got that kind of pattern going on, you want to talk about seek.pairwise, because that does exactly that. It gives you the first and second elements, then the second and third elements. So how do we add those all up? Well, it's ridiculously easy. We say sum by, and what do we want to sum by? We want to sum by the distances between each pair of points, and we already have a function to do exactly that. That, by the way, is why I tupled those two arguments together rather than using the kind of more normal convention of currying them like that, so they're kind of completely separate and can be applied separately. Because seek.pairwise returns a sequence of tuples or tuples. So let's just restore that to its former glory. There we go. So that is almost embarrassingly simple to do. So how are we going to get the biggest perimeter in a file? A shapefile, that is. Well, and we're just going to deal in individual shapefiles initially, and then we'll work out how to deal with all the shapefiles, because there are several that make up the UK dataset. Let's take a file path. That's one specific file. I'm going to just risk using use again on this, just in case we're okay with that. Use the file path to create the shapefile. Do the same seek.init thing we did here. I missed out part of that. There we go, that's better. So at this point we've got that sequence of sequences of polylines, or sequence of arrays of polylines. If you want to get the biggest thing in a sequence, often it's useful to go seek.maxby. And what will we have available here? Well, if I kind of forget what I have available, I kind of call it x, and I just return something silly from my function. So at that point I can hover over x and see what I'm getting. I'm getting a collection of arrays of points. So let's just call that point groups. Let's take point groups. Let's join them up into one big sequence. Remember, we said we didn't care about sort of separating out the voids. We'll treat them as part of the perimeter. So if we've got a building that's kind of like Swiss cheese from up above, then it'll score more because its holes will get measured as part of the perimeter. And then we can actually go ahead and call polylength, because that expects the arguments which point groups to seek.concat will return. Get rid of a spurious bracket there. And let's just have a sample bit of code where we call it here. And this is the shape path string we defined up here, which is just the Wales buildings. So let's send that across as well. Right, so we've got what looks like a fairly complicated building. How do we verify that that's a large building in Wales? Well, here's where we get to do a bit of cheating. We just pick, it doesn't matter which point we pick, so I'll pick what I'm guessing is something like the top left corner of the building, or maybe the bottom left. Copy that, the X and the Y. Go to streetmap.co.uk, and if you look at the arguments there, it too takes a X and Y parameter, the easting and the northing, and also like a zoom level parameter. So let's just replace that bit, paste what we copied. The comma needs to be a kind of HTML or HTTP query argument separator. We'll just take it on trust that that's the right zoom level. Right, hold your breath. Port Talbot. Well, if you know anything about Wales, and I don't necessarily expect that you do, Port Talbot is famous for one thing. Let's just zoom in and see what that thing is. Port Talbot Steelworks. Well, that is a pretty big building, and I think it's a fair bet that that's the largest building in Wales. So we have got a credible result first time from our fairly simple query. Let's just return and review the code for that. So we took a file path, we opened a shapefile, we made a sequence from that shapefile by calling getShapeData for every record in the file. Then we found the record that has the maximum poly length, and that gave us the biggest building. Now, how do we do that for the whole of the UK? Well, not hard. Let's take a dir path, and let's take a file pattern as well, so that we can limit it to Wales, or we can use the whole of the UK. Let's actually open the system.io namespace. Okay. Do an enumerate files on that dir path using that file pattern. And for every file, so seek.map, we're going to produce something for every file. Take a file name, create our shapefile based on the file name. I'm guessing we'll probably, as we're in the middle of a sequence, probably be safer to use a let rather than a use there. That needs to be file name. Now at that point, if I hover over here, we're producing a sequence of sequences. And any time you do that and you don't want to be doing that, one way is to concatenate all the sequences together with seek.concat. We will return to that, but that will do for now. And then we can just copy our max by. So that should produce the biggest building in the UK, or for all the shapefiles in whatever direction we choose. So that is the path to my data. I've misspelled perimeter here. I'm going to say all the shapefiles, just print out the result. So let's send that across. It's gone across. Now, while we're waiting for that to complete, you might like to have a think about which is the largest building in the UK. I had my own private theory about this, but we'll see if we can guess it correctly. Right, that's completed. Let's pick a point in the result set, copy it, go back to Street Map, Let's make that little edit there, ampersand. Did you guess right? Heathrow Airport. And yes, that is a fairly big building. If we just scroll down here so you can see the scale, it's well over a kilometre on a side. So that's a pretty good candidate for the biggest building in the UK. Now I did say we'd return back to where we used a seek.map and a seek.concat to produce a sequence of sequences and then to collapse that into one sequence. Whenever you see that combination, you know you can replace that with a seek.collect, which does those two operations in one go. Let's make sure that still works. And there we go, got the same data back. Right, so back for some acknowledgements now. Well, firstly, thanks very much to Alistair Ray for making that data set available. Big props to you. The other thing is just to call out the copyright on the data. You can use OS Open Data Map datasets in any way for any purpose, but as I'm doing here, you need to acknowledge the Crown copyright and database right, and for the record, this year is 2017. And last but by no means least, let's not forget the aegis.shapefile lib NuGet library and the authors behind that. This thing performed flawlessly throughout the demo, and of course it's the thing that actually did the heavy lifting. Now this is a very big data set, so if you don't have the bandwidth to download all of it, it's well over a gig. Please hit me up on Twitter at KitLovesFSharp or put a comment in the YouTube, and I'll see if I can ask Alistair Ray if we can have a Dropbox place where it's just got, say, Wales. So thank you very much for listening, and have fun with F# collection functions and F# in general. Keep listening. Bye!